equation, blah, blah, blah. Which of the following is an equation of the tangent line at the point 3, 8? So in order to find the equation of a line, which is what we're coming up with, what's that form of a line that we really like in this world? Yeah, y minus y1 is equal to m times x minus x1. So what do we already have?
y1 and x1.
Yeah, we already have y1 and we already have x1. So what's this entire question revolve around? Finding the slope. And you need to remember dy dx, what's that nice little relationship? Do you remember what it is? Is equal to, anybody remember? dy dt over dx dt, right? Is that correct? Yeah, so can we find dx dt? Yeah, what is dx dt going to be equal to? 2t minus 4. And what's dy dt equal to? 3t squared. Now, you need to know what time it is at this point. You see that point right there? So we can find each of those values at that time. So we let negative 3 equal t squared minus 4t plus 1. And we also know that 8 has to equal what? 8 has to equal what? Does everybody understand what I'm doing? The whole idea of a parametric equation is there's a particle that's traveling along a path which gives its position at specific times. So at negative 3, 8, we need to figure out what time it is. So it's going to be 8 equals t cubed. So what does t have to be? 2. But what's the thing you have to check? You should check, and it should work. Does it work in this one, right? Let's try it here. 2 squared minus 8 plus 1. That's going to be 4 minus 8 plus 1. So that's going to be negative 3. Does that work? It does. Does it always work? No. That's something you sometimes have to check. This time, you kind of assume it does, so it's time equals 2. So at t equals 2, what does this equal? 0. And at t equals 2, what does this equal? Come on. When you plug in 2 into this, kids, I'm not trying to trick you here. What does it equal? 12, right. But so what do we now have? We know that this is equal to dy dt is equal to 12 over what? 0. So what does that mean the slope is? Undefined. So slope equals undefined. So what does that mean the line is? What kind of line is it? Therefore, a vertical line. What form do all vertical lines take? X equals some constant, right? But we know what x has to be, right? Negative 3. So it's a vertical line, x equals negative 3. Does that make sense? Which ones can we eliminate? Yeah, if a is equal to negative 1 right here, if a is equal to negative 1, we have x to the, or x is, let's say, negative 2, right? If x is negative 2, we have 1 over x to the negative 4th, which is x to the, what is 1 over x to the negative 4th? What is that equal to? That's x to the 4th. So is that going to converge? No, it's not. So what can we eliminate immediately? What can we eliminate? We can eliminate a. We've got those, right? Okay. What about b? Yeah, let's say it was equal to, what do we want it to equal to? Like x, well, p is greater than 0. Can you find something? What's the test we should run on this? Oh, come on. No one looked up any convergence tests? Don't you have a list of convergence tests somewhere?
Really good list of notes, and I don't.
Goes up by 1. N increments 1. What does that mean? Grows by what? By 2/3. Right. Exactly. So what's our first value? 4/3. What's our R value? 2/3. You might have a formula you could use. So kids, if you get totally lost, look at the elements. I can't tell you how many times the AP test will give you something like can they give you something much nastier than this and just have it be a geometric series? Absolutely. So then you're just, oh look, it's 2/3. As you increment the numerator by 1, it goes up by a factor of 2, and as you increment the denominator by 1, it goes up by a factor of 3. It better be less than 1. Because what happens if the ratio is greater than or equal to 1? It diverges. It diverges. But since it is equal to, it's less than 1, it's 2/3 in this case, we are set. Ali. For finding the perfect method the first time. Stop it. This isn't like free throws where you're aiming for I have to get it right every single time on the first attempt. You can try things. So I like that idea. So maybe we multiply by what? X squared. If we multiply by x squared, what do we end up with? X squared over?
X squared minus x cubed.
X squared over what? No, x squared over 1 minus x. Is this closer to that?
Yes.
It's closer to it.
Multiply by 1 over 1
Ah, so then what do we need to get to? What does this factor into right here?
X plus 1, x minus
1 plus x times 1 minus x, right? So what could we multiply this by?
1.
1 over what? 1 plus x, exactly. So theoretically, to get from this, we multiply it by what? X squared over, and what do we end up with? What we want. We end up with what we want, right? So the thing is, we have this expansion right there. It tells us what it is. What's the original expansion? The original expansion is, it's x to the n, right? Starting with
n equals 0.
n equals 0, right? So what's the first term?
1.
1. So this original series right here, what does it expand to?
1 plus
X to the 0 plus x to the first plus
x to the n.
all the way to x to the n, right? So what are we going to multiply by?
X
Let's multiply by x squared first and see what happens, right? What do you end up with? X squared plus x to the third plus x to the
4,
fourth plus x to the
5,
fifth all the way up to x to the
n plus 2.
n plus 2, right? Again, am I sure this method is going to work? No, but I like trying it, right? What are we now multiplying by? 1 over what?
1 plus x.
1 over 1 plus x, right? Is that what we multiplied by? Yeah, 1 plus x, right, exactly. So then we have to ask ourselves, right here,
The first term is still x squared.
what happens when we start multiplying this in? What do we end up with? We're trying to make it match this, right?
Oh.
We're trying to make it match that. So we have to see if there's a way to clean this up. There's sometimes clever ways. And again, I'm not guaranteeing this is going to work. I like trying things, seeing what we learn, and maybe reevaluating. That's totally fine. Be the answer. It's really nasty if it doesn't. That happens every once in a while in the SATs. I had a friend in high school. She had a challenging time applying to colleges, not because her application wasn't awesome, it was too awesome. She took the SATs, and there's a few people that do this once every like decade. There's a mistake on the SATs. It happens, right? Do you know what happens if you find the mistake and report it? You get points. You get extra points if you find it and report it, right? You get like 60 points. And it was out of 1,600 back then, right? But then do you know what she also did? She got a perfect, right? She got a perfect and found the mistake. So you know what her SAT score was? 1660, right? So do you know what happened when you apply to colleges with a 1660? You have to send like notarized scores from the college board in like blood, right? With like your finger, like proof of life, you know, because they think it's a mistake, right? They think it's a mistake. So getting back to this, we have to see if we can press R. See what the first few are. What kind of number is this?
A finite number.
That's a constant, right? That is a constant, like sine of 2 over pi. Sine of 2, right? That's some constant, right, to the n. So what question do you have to ask yourself on that?
Does x
E to the n plus 1, that is what?
1
So therefore it has to what?
converge?
It diverges. This has to go to 0 for it to have any chance of converging. This goes to 1, so therefore it definitely what? Diverges. So that reinforces D for the answer. Yeah, we're done. Nice. Is it exciting? What's really nice about it is I also gave you the answer key at the same time. So as you work through them, you can check what you're doing.
Oh, that would be great. We can study. Sorry.